Good afternoon, children. Welcome to 8th standard online physical science class. This is 8th standard physical science class. A continuation of physics 6th lesson. Heat. Lesson topic is heat. So in the previous class we have discussed about that thermal expansion. So expansion of metals due to the heat is called as thermal expansion, and contraction is known as the negative thermal expansion. We have learned, isn't it? So today's topic is coefficient of linear expansion. Coefficient of linear expansion. We have already studied what is a linear expansion. If the changes in dimension, area or volume of a body, then we call it as a thermal expansion. Linear means if it expands in straight line process, we call it as a linear expansion. So coefficient of linear expansion, what is this coefficient of linear expansion? The change in length per unit length of 1 degree Celsius change in temperature is known as the coefficient of linear expansion and is usually denoted by alpha. Okay, it is usually denoted by alpha. See, this is alpha, symbol for alpha. Okay, this is called as alpha, ALPHA, alpha. Alpha means it's actually the name of the first alphabet in Greek language. Okay, so like A, we are saying A is the first alphabet of English, no, like that alpha is the first alphabet of Greek language. So this linear coefficient of linear expansion is denoted by alpha. Okay, children, do you understood this? Hope you have understood. Yes, what is it actually? The change in length. The change in length per unit length. So for 1 unit of length under the 1 degree change in temperature, that is known as coefficient of linear expansion. So this has different value for different metals, and the unit of all the coefficient of expansion is expansion is expressed in degree per Celsius or Kelvin per Kelvin. Okay, degree per Celsius, per degree Celsius or per Kelvin. Okay, then some of the metals and their coefficient of linear expansion are expressed here. For copper it is 1.7 into 10 power minus 5, brass 1.8 into 10 power minus 5, iron 1.2 into 10 power minus 5, aluminium it is 2.5 into 10 power minus 5, silver 1.9 into 10 power minus 5, gold 0.29 into 10 power minus 5. So these are the coefficient of linear expansion of some of the metals. Now the next one is superficial expansion. So we have learned what is linear expansion. Now we are going to learn about superficial expansion. What is superficial expansion? If a sheet of thickness negligible compared to its length and breadth is heated. Okay, a sheet of thickness whose thickness is negligible. Okay, very thin sheet. When we compare the length and breadth of the sheet, if it is very thin means if the sheet is heated, so there is a far greater change in its area compared to the change in its thickness. So that already the thickness is very less. So when you heat, if you are using a metal sheet like that, means the metal sheet, what happens? It expands in its length and breadth, whereas there is no considerable change in its thickness. That is known as superficial expansion. Do you understood what is superficial expansion? And this superficial expansion is denoted by the superficial coefficient of superficial expansion is the change in area. There we have studied in length. Here the change in area per unit area of 1 degree Celsius change in temperature is known as coefficient of superficial expansion. Okay, coefficient of superficial expansion is nothing but change in area by original area into 1 by change in temperature. They understood, children? So, and it is denoted by the symbol beta. The symbol is called beta. This is the symbol of beta. Beta Again, it's a Greek word, beta. How it is pronounced? Beta, B-E-T-A, beta. Okay, so this beta is the alpha. It represents the alphabet B in Greek language. Okay, children. So superficial expansion symbol is beta. And what about this linear coefficient of linear expansion? Its symbol is alpha. Keep in mind. Okay, children. You understood this superficial expansion? Hope you so. Now, volume expansion. Okay, volume expansion. What is volume expansion? The change in the volume of a body or a substance with the change in temperature is called volume expansion. Okay, for example, if you are heating a metal ball, select a metal ball and a ring. Okay, make sure that the ball can pass through the ring. So heat the ball and again repeat the experiment. After heating the ball, you are not uh, you are not able to say yes pass the ball through the ring. Why? Because while heating, the volume of the metal ball has expanded, so that the volume, since the increase in volume does not allow the ball to pass through the ring. Okay, only it can pass through the ring after cooling. So this is called volume expansion, and this type of expansion is relevant in the case of liquids and gases. Okay, this volume expansion only happens can happen in gases and liquids, whereas this linear expansion or superficial expansion is not possible in liquids and gases. Is it clear, children? Okay. Now, what about the coefficient of volume expansion? The coefficient of volume expansion is um, the change in volume of a body or a substance. The change in volume per unit volume of for 1 degree change in temperature is known as the coefficient of volume expansion, and it is usually denoted by gamma. Okay, this is called gamma. This is called a gamma, and you can represent it is called as gamma. G-A-M-M-A, gamma. Okay, children. So alpha, beta and gamma. Do you understood this? Yes, this has different value for different metals. Okay, this also has different values for different metals. Do you understood this? Here the coefficient of volume of some materials are discussed here, and for copper the coefficient of volume expansion is 6 into 10 power minus 5. Brass, it is 1.8 into 10 power minus 5. Iron, it is 3.5 into 10 power minus 5. Aluminium, 7 into 10 power minus 5. Mercury, 18.2 into 10 power minus 5. Water, 20.7 into 10 power minus 5. Paraffin oil, 76.4 into 10 power minus 5. Ordinary glass, 2.5 into 10 power minus 5. Chloroform, 127 into 10 power minus 5. Ether, 160 into 10 power minus 5. Ether is a form of chemical. Okay, children. So different metals have different coefficient of volume expansion when they are heated. Okay, so far we have learned about this three coefficient of expansions, isn't it? So how can we relate them? How can we relate all these three coefficient of volume expansion and linear expansion and superficial expansion? We can relate the three coefficient of expansions as alpha is equal to beta divided by 2 which is equal to gamma divided by 3. Okay, alpha is equal to beta divided by 2, which is equal to gamma divided by 3. Okay, alpha is equal to beta by 2. Alpha is also equal to gamma by 3. Okay, similarly when you relate beta by 2 equal to gamma, beta by 2 equal to beta by 2 equal to alpha, beta by 2 equal to gamma by 3, or gamma by 3 equal to alpha, gamma by 3 equal to beta by 2. Okay, children, do you understood this relation? So this relation you must remember. Okay, this is very important one. Okay, this you must remember always. So alpha is equal to alpha equal to what? Alpha equal to beta by 2, which is equal to gamma by 3. Do you understood? Yes. So the various uses of thermal expansion in our day-to-day life, we know that in the railway tracks and all, small gaps are left in between the tracks. Why? Because between the tracks, why? Because they will expand during the summer days and they will contract during the winter days, isn't it? So similarly in bridges also, you might have noticed a small gap will be between their wheel teeth. Why? Because of this thermal expansion. Due to the hot sun, they will expand and shrink, so that it can what to say, it can overcome that expansion process. Okay. And also, while this one also we know, fitting a iron rim in the wheel, that also the concept of thermal expansion. Also we have learned about this bimetallic strip in our 7th standard class. This bimetallic strip is a device, electrical device, which is consists of two strips of equal length of different metals or alloys riveted together. Okay, two different metals are riveted together, and when it is heated it bends because the strips expand unequally. This cut off the current flow and ensures the temperature does not rise beyond a particular value, because the strips expand and cut the current supply, and the device will not overheat heated, and the current circuit will not be spoiled. This is actually used in normally used in water heaters. Okay. And also expansion comes in handy when it is difficult to take out the cork from a bottle or open the metallic lid of a jar. Just place the neck of the bottle in the hot water, or holding the jar upside down with the lid in the hot water solves the problem. So the hot water will expand the neck of the bottle so that the cork can be easily removed. Okay, children. At the same time, this thermal expansion can also be troublesome too. If boiling point is poured into a thick walled glass vessel, the glass vessel may crack due to the unequal expansion of different layers of the vessel. The outer layer will be chilled, but the inner layer will be hot. So it will expand. But the outer layer it will not. So this makes the glass vessel to crack. Okay, that's why it is advised not to pour very hot liquids to the gas vessel. Okay. Yes. Next comes the expansion of liquids. So as in the case of solids, the liquids also tends to expand. For liquids, real expansion is equal to expansion of the vessel plus apparent expansion of the liquid. So we have to consider the expansion of the liquid as well as the expansion of the vessel also. Okay. For example, consider a flask as shown in the figure. The initial level of the water in the flask is A. Okay, this A is the initial water level. And what about when the flask is heated, the level of the liquid first falls to B. Okay, when you heat, the water level will come down to B, isn't it? Yes. Then because the flask absorbs heat first and expand, so the flask will first expand. Then the liquid gets heated and rises to C. After the vessel get heated, the liquid get heated and it rises to C. Therefore, it appears that AC is the increase in the level of the liquid. So we can say this part is the increase in the level of the liquid. But the real increase in the level of the liquid is BC. BC is the real increase in the level of the liquid. Therefore, the real expansion of the liquid is equal to the expansion of the vessel plus apparent expansion of the liquid. Okay, the expansion of which is the expansion of the liquid, volume of AB, isn't it? Expansion of the vessel is this one. This part is the expansion of the liquid. Am I right, children? This AB plus the apparent, the expansion of the liquid, that is C and B. Okay, so totally from here to here only we will get the real expansion of the liquids. Do you understood? So real expansion equal to expansion of the vessel plus apparent expansion of the liquid. Is it clear? So in general, the thermal expansion of liquid is greater than that of solids, and then that of gases is far greater than the thermal expansion of liquid. Hence, gases in general have the greatest coefficient of expansion. To explain this, let us do some activity. Fill up a balloon with air, tie its mouth firmly, hold it in a hit a little above a burning candle. Do not bring it too close to the flame. In a while, the balloon will burst with the pressure exerted by the heated air. Okay, so the pressure of a gas conified in a particular volume increases as its temperature increases. So when you increase the temperature, the volume also, the volume of the gas increases. That's why what happens to the balloon, it burst out. Okay, we understood. So the expansion of the gases is the highest when you compare with solid and liquid. Solid is the least, and liquid is the middle one, and gases is the highest one. Okay children, do you understood? This is about this lesson. Hope you have understood the lesson well and enjoyed the lesson. So we will meet in the next class children. Until then, do your assignment and keep on preparing for your upcoming exams without fail children. Also report in the group without fail. Thank you children.